33 would be undefined.
No, it's a horizontal.
Would be Oh, okay, because y equals 100.
Yeah,
That makes sense.
let's look at that.
Okay.
If I'm drawing the xy axis,
Mm-hmm.
well, this is the y grid. So if y equals 4,
Mm-hmm.
it means that y
Horizontal.
equals 4 no matter what x equals. X can equal
Okay.
5 and y is still equal to 4. X can equal minus 10 and y is still equal to 4. So
Okay.
y equal numbers are horizontal lines. X equal numbers are vertical lines. This line might be x equal 3. So these are the ones that are undefined.
Okay. That makes sense. Cool.
All right.
Okay.
Today, I think there's more algebra that I want to cover, but let's get back and do a little more geometry. The
Okay.
only algebra that I still want to cover is
Mm-hmm.
solving a system of two equations and two variables.
Okay.
That's a skill that you're going to need for a lot of things, but
Mm-hmm.
there's a lot of geometry skills you're going to need for next semester. So
Yeah, for sure.
I kind of want to get back to preparing you for next semester.
That's
Now,
awesome.
rather than, this is my favorite geometry instruction material right here.
Okay.
Um, if
Mm-hmm.
you can do the things that are on this, I consider your geometry skills to be pretty good. They may
Okay.
not help that much with some of the things you're taking in geometry class, but we're just going to have to encounter that when we encounter that.
Yeah.
What we're going to cover here for geometry is the stuff that you're absolutely going to need. This stuff for the ACT test, for most any math test that includes any kind of geometry. This is the geometry they want you to know.
Cool.
Okay.
Okay.
So
Okay.
what we're going to do here is I'm going to do the even ones.
Okay.
Or we're going to do the even ones, and then your homework's going to be to do the odd ones.
Sure. Okay.
And how fast we go through these, if you can do them really quick, we don't need to spend a lot of time on them. There's a lot of sections for geometry. So
Yeah, definitely.
we've got plenty of material here. No, I mean, digitally, we got lines and angles, we got triangles, we got circles, we got quadrilaterals to deal with, all of these things. So
Okay.
let's, this is in fact, I'm not sure what this is. Doesn't matter. These are still good questions. We'll
Cool.
advance forward. So number 2.
Okay. All right.
These are
I've always.
these are stuff you should be able to do.
Okay.
If we get to one that you tell me you don't think you've covered that so far in geometry, you let me know. But I think this is stuff you should be able to do.
Okay. 2 would be J. Well, like we briefly went over like number 2, like those kinds of problems.
No, I know. Even if you haven't been over it, this is what we want to go over. Because if you haven't been over it yet, this is coming up, and what better stuff could we go over than the stuff that's coming up? But
yeah, exactly.
I honestly think that you've been over most of this stuff.
Yeah.
So what does it mean if line AB is equal to line BC?
They're congruent to each other.
Okay. And
Or it's an isosceles.
It's even
Isosceles.
it is isosceles with AB equal to BC. So what does that mean about these two angles?
That they're equal to each other.
Okay. So what are they?
Adjacent angles?
No, I don't need terminology. What
Oh,
numerically are the sizes of them? In other
oh
words,
60.
65.
65.
Hold on one second.
Okay.
Yeah, 65. In other words, that one 65, that one's 65, because then those would add to 130, and then add it to that one, and would add to 180. Remember,
Oh, that makes
the
sense.
magic number is 180 in geometry. Always, never
Yeah.
forget that. If you have any
Yeah.
skill at all that you would, wish to have, it would be subtracting numbers from 180.
Okay.
Believe it or not,
Cool.
that is a terrific skill to have for geometry, is the ability to subtract numbers from 180. Notice that we
Mhm.
have this angle now we know is 65 degrees. So
Yeah.
how do we get that?
We do 180 minus 65.
Right.
Okay. Cool.
So
Which would,
that's 115.
yeah.
Okay, let's look at number 4. Hold on, let me get my, in case I need to do any drawing here.
Sure.
May or may not need to.
Okay.
This has a beginning, intermediate, and advanced sections, I believe. I don't know. I had a little trouble
hmm
finding these, but we'll just go whatever we come across here.
Awesome.
Similarity. You've done similarity.
Yep, we have. hmm so in the figure below, A, B, C is similar to D, E, F. A corresponds to D, B corresponds to E, C corresponds to given line, so the same unit.
In other words,
Um,
that entire paragraph
hmm
can be summed up in the statement that that's similar to that and they're oriented the same way.
Yeah.
In other words, this one is not rotated.
No, it's the same.
It could still be similar even if it was rotated, and it can be much more confusing that way. But always know that when they're oriented properly with respect to one another, then figuring out corresponding sides is easy.
Yeah,
What's
exactly.
what's the similarity ratio, first of all?
Um, well, for like this problem or
For this set of similar triangles. In other
okay,
words, what I call the similarity ratio is the ratio of the big to the small.
okay, that makes sense. So for this one, we would set it up 68 is equal to 3 over x.
Hold on.
6 over 8.
Let's write the equation. 6 is
Oh,
to 3,
oh, okay.
and
Oh, and then 8 is to x.
is to x.
Okay. And then it would be 6x is equal to 24, and then x would be equal to 4.
Right, right.
Okay.
Now, here's the thing about similar triangles, and
hmm
one reason that it's easy to get confused by
hmm
them. And that is that, so this is a 6, 8, 7, and this is a 3, 4, 3.5. So you have your basic ratios. In other words, the corresponding sides have proportional ratios. 6 is to 3, as 8 is to 4, as 7 is to 3.5, right?
Yeah,
But you
exactly.
also have, within the same triangle, 6 is to 7, as 3 is to 3.5. Or
hmm
6 is to 8, as 3 is to 4.
hmm
So not only can I establish ratios between two similar triangles, but I can establish ratios between the same sides of a triangle. You know what I'm saying?
Yeah. Uh-huh.
In other words, it's one thing to say that, the ratio of this side to that side is the same as this side to that side. But
hmm
it's also true within the ratio of this side to this side is the same as this side to that side. So
Okay.
you can always, usually when you're trying to solve similar triangles though, like in this case, in order to solve for x, I actually
hmm
could have done it either way. Notice what the other relationship I can say is 6 is to 8, as 3 is to x. And I still come up with x equal 4.
Exactly.
So,
okay. Cool. Okay.
And let's see, I think I got to go to my next page here. That was 154.
Okay.
My database is so gigantic here that it is finding.
Wow.
And I got copies of them besides.
Gotcha.
155. Okay, we'll do even ones again, and then I'll have you do odd ones for homework. That actually works perfect.
Yeah, definitely. Okay. So in the figure below, AC is perpendicular to BD.
Which is also stated by that. In other words, most of these problems, whatever they say there, is you can look at the picture and figure it out. Everything else they say there is in this diagram. Really, the only thing you need from this paragraph is the last sentence. In fact, the last half of the last sentence. How long is AB? What is the measurement of that right there?
Okay.
Okay.
Alright. Okay.
So, let me draw my picture. Now, geometry problems are classic where you can't figure out what you're trying to figure out in one step. You have to do it in 2 steps.
Yeah. So, like, you could split the triangles up into, like, two triangles.
Exactly. Okay, so if this is a right angle...
we already know, well, it's 90 and 30 for, like, the one on the right.
Let's analyze the triangle on the right. Here's our plan of attack. Is we're going to figure out what this side is right here, based on the triangle on the right. And then we're going to use the length of that side to figure out what the hypotenuse of the triangle on the left is.
Okay.
Now, let's talk about these 2 triangles. Because these are the 2 most important right triangles you're ever going to study.
Okay.
So what I want you to do is, above all else, memorize these dimensions that I'm putting. On these, what I call these are my unit right triangle. And the reason I call them my unit ones is because the dimension of the side opposite the smallest angle is 1.
Okay.
That makes the dimensions of the other sides this.
Okay.
So if there's ever anything you want to memorize in geometry, memorize this picture right here. Be able to recreate that at any point in time, and that will serve you so well for the rest of your math career, you can't imagine it.
Yeah.
Okay. Now, given this set of dimensions down here, and given how does this triangle right here compare to this triangle?
Well, they're both right angle. Have a right angle in them.
Are they congruent? Are they similar? Are they what?
They're similar.
Okay. That's the key.
Yeah.
So what is the similarity ratio? Big to little?
Yeah, big to little. It was, like for this problem.
Here's the big. Here's the little.
Okay. So it'd be x to 1.
Hold on. Just give me a number. In other words, we have the measurement of 2 corresponding sides. That's all you need for the similarity ratio. This hypotenuse is 6. This hypotenuse is 2. they have
Okay.
to be the corresponding sides. If you have right triangles that are similar to one another, then their
Mm-hmm.
hypotenuses are the corresponding sides. The short side is corresponding to this side. This long side is corresponding to this long side. So the
Okay.
key to figuring out the measurement of that side is figuring out the similarity ratio.
Okay.
Similarity ratio going to be?
Okay, so it's going to be, I'm so confused.
Okay.
So,
Here's the big triangle.
yeah,
Here's the little triangle.
okay.
They are similar because you've already deduced that they have the same three angles. This is
Yeah.
30, 60, 90. This is 30,
Mhm.
60, 90. So
Okay.
when you're dealing with similar triangles, the very first thing you want to know, once you've determined they're similar, is what the
Mhm.
similarity ratio is. That may not be what your teacher called it. It could be the linear ratio, but it's the ratio of one corresponding side to its corresponding side in the other triangle.
Mhm.
In other words, 6
Okay.
to 2.
Yeah. So I got that. And then
Hold on.
so it'd be six. Yeah.
So 3 to 1. So every side on this triangle is 3 times bigger than every side on that triangle. That's what that means. When I say I have a similarity ratio of 3 to 1, that's what I'm saying.
Okay.
I cannot say that this triangle is 3 times bigger than this triangle, because in reality it's 9 times bigger.
Mhm.
When I'm
Yeah.
comparing their areas, this triangle and this one's going to have 9 times as much area in it as this one. But
Okay.
it's linear ratio. It's similarity ratio. Similarity ratio specifically means the linear ratio of one corresponding side to its other corresponding side. Well, when you're comparing right triangles, it's pretty easy because you know for sure that the hypotenuse is the corresponding side for
Mhm.
both triangles.
Okay.
Okay, so my similarity ratio is 3 to 1.
Okay.
What does
And
that
then for like,
what does that make side AC has to be equal to?
so if it's 3 to 1, AC would have to be 3.
Okay, good.
Okay.
Now, to solve this triangle,
Yeah.
we got to go to this picture over here.
Mhm.
Notice that
Yeah.
this triangle is similar to this triangle. It's not oriented exactly the same, but we don't need it to be. What's the similarity ratio of this triangle to this triangle?
Um. Just well, it would
Notice,
be
notice this is isosceles. That
yeah.
triangle's
So
45, 45. So if this side's 3, that side's 3. So
okay.
what's the similarity ratio?
3 to 1 again.
What's the hypotenuse? What is x?
And then x would be square root of 4,
Hold on.
or
This has to be 3 times bigger than that.
yeah. So it'd be the square root of
3,
6.
3 root 2. When I
3 root.
say what is 3 times bigger than root 2, it's this.
Oh, it's asking for
That's
the
what that
root.
means. That means 3 times root 2.
Okay, that makes
Okay?
sense.
So that's
Okay.
what x is
Okay.
3 root 2.
Okay. So 6 would be G.
Yes.
Okay.
Okay?
Cool.
And this is the definitive problem. If you can do this problem, you can go a long way in geometry. Because
Mhm.
this problem incorporates the concept of similar triangles, and it
Mhm.
also requires you to know these two triangles down here.
Yeah.
Notice that you're not normally given 2 dimensions of these triangles. You're usually only given 1.
Uh-huh.
For this triangle here, they only gave us 1 dimension, 6, 1 side length.
Mm-hmm.
So if I didn't know what the standard dimensions are of my unit 1, I wouldn't be able to figure this out.
Okay.
So I must know this triangle. And by knowing it, I mean be able to label it like I've labeled it.
Okay.
Same with this one and this one.
Mm-hmm. Yeah.
Know what these are.
Okay.
Okay.
Mm-hmm.
What is the area in square inches of a circle with a diameter of 8?
That would be F4 pi.
Hold on.
Because the diameter is the whole circle, so like, what is, the area in square inches.
All of our formulas for circles really have to do with radius, not diameter.
Yeah.
I mean, it's true you can say the circumference is equal to pi times the diameter, but I don't even like doing that. Radius is such a big number in geometry. Area is pi r squared, circumference is 2 pi r. I never write circumference this way. Not since I was in high school. And there's a reason. This looks simpler. And you're given the diameter a lot of times. The problem is that radius defines everything you need to know about a circle. That's why a circle is such the perfect object in flat geometry, and why spheres are the most perfect objects in the universe. And it's because they're all defined by one number only, radius.
Okay.
Okay, so what's the radius of our circle?
The radius would be 4.
What's its area?
So the area would have to be 16.
16 pi. Notice all these answers
16
have
pi.
pi in them. Notice
Yeah, my bad.
we never convert pi to a number anymore.
Okay.
Okay, these 2 formulas here must know.
Mm-hmm.
Never forget either one of these.
Okay. Okay.
The stuff we're covering today is must-know geometry stuff.
Yeah, definitely. Okay.
Let's just keep going. I like 155, so let's go to 156. These may get a little bit harder, but that's okay. Yeah, this is actually just the example geometry test. Good. We'll do 10.
Okay.
Let me look at it first.
Okay.
I like this problem. It's not probably the kind of problem you've been studying in geometry, but all of these problems incorporate so many good principles that you need to know for your basic geometry that I like them. Let's do them.
Okay, cool.
Now, first of all, whenever you see a question that says, what is the area of a shaded region? It is always a subtraction problem. As you can tell by the answers, they're all minus.
Yeah, exactly.
Okay? But it's like if I said to you, well, I'm going to draw a circle and I'm going to put a square inside that circle, and I want you to tell me the area of this part right here. We don't have the geometry to figure out that area. We have no idea how to figure out the area of something that looks like that.
Yeah.
Okay? So I can't do it directly. I can only do it indirectly. And by indirectly, I mean I can figure out the area of the circle, And I can figure out the area of the square. So if I take the area of the circle and subtract the area of the square, I'm going to get the area of this total amount.
Okay.
Okay, so shaded region problems, understand, and they're big on the ACT test. They give you a lot of them. They
Yeah,
are
definitely.
subtraction problems. Know that from the start.
Okay.
So, what if I want to draw this problem? I can really kind of draw it like this. Don't have to draw it the way they drew it.
Yeah.
I only care about that semicircle, right?
Uh-huh. Yeah.
And
Okay.
they've told me the diameter of that circle. If I draw the whole circle, I will, just so it looks similar. But I don't care about this part over here.
Okay.
What's the area? What's the shaded region going to be?
The shaded region is going to be 50
Hold on.
pi.
Hold on. Let's break it down. We're talking about the area of the square minus 1/2 the area of the circle, right? This is the way I would like you to think about geometry questions. Rather than immediately coming up with an answer, in other words, rather than focusing on speed, I'd like you to take it step by step, starting with what am I doing conceptually? Well, I'm going to figure out the area of the square. I'm going to subtract half of the area of the circle, and that will leave me with this shaded region. So what's the area of the square?
So the area of the square would be, well, if the diameter is 10, the square is going to be half, so it's going to be 5.
No. The area of a square is the side squared. So whatever the side, the definition of a square is 4 equal sides at right angles. So you get its area by base times height. Base times height is 10 times 10.
Okay, yeah, so the side is 10, so it'd be 100.
Okay, so that's 100.
Okay.
Minus 1/2 the area of the circle. What was the formula for the area of the circle?
It was area equals pi times radius squared.
What's our radius?
5.
What's our area?
Our area is 100.
Hold on. Don't.
Our area.
Fill it in. In other words, if our area is pi r squared and our r is 5, what's area going to be?
Then the area is going to be 10 pi.
What's 5 squared? Not 2 times 5, but 5 squared.
Oh, yeah, 25 then. My bad.
So
25 pi.
5 pi is the area of the whole circle.
Okay.
Okay, so I can write 25 pi right in there.
Okay.
And we want half of it because it's only half of that circle that's in our square. This half over here is not inside of it.
Yeah.
So that's why I'm taking out half. And that makes the answer H.
H. Okay. Yeah.
All right.
Okay.
157. Now I remember what happened here. All right, we're going to go to lines and angles. Yeah.
Okay.
Now I remember these aren't in order.
Okay.
I jumped out of order a little bit, but not bad, and we'll eventually definitely get to those 4 pages.
Okay, cool.
But this is the lines and angle basic questions.
Okay.
How much is X? Oops, hold on. We're going to do even ones only. You're going to do odds on your own.
Cool.
Let's do 2 and 4.
Okay. Was measures.
They want to know AOE.
Okay. wouldn't it be 105?
Notice that
Because is that vertical?
no, not quite. AOE
No.
is not vertical to BOC.
No.
It's vertical
Okay.
to what? What is it vertical to?
Um, BAO is vertical.
AOE has only one vertical angle. What is it?
Just D.
BOD,
Wait. BOD. Okay.
right?
Yeah.
In other
Yeah.
words, you have to eliminate this line from your mind to see it.
Hmm. Yeah.
What you're looking at is two lines that cross. AD crosses BE. So
Hmm.
this angle right here has only one vertical angle, and that's what? From there to
Uh.
there.
Yeah.
So what is it?
Okay. So it would
What is
be
its measurement, I should say?
145.
Okay, good.
Okay.
Number 4. What's the value of x plus y?
Okay. So we know that it's 90 degrees in that angle. So would it have to be 30 plus 30?
Well, notice they're not
Well,
asking for x. They're asking for the sum only.
okay.
We don't know what x and y are because I could
No.
tilt this thing. I could tilt that in any number of ways so that that would still be 90 degrees, but it would make x smaller and y bigger. Or if I
Hmm.
tilt it to the right, if I want to rock it to the right, it's going to make y smaller and x bigger. So there's
Yeah.
no way to know what x and y are. They're not necessarily equal. They don't say that they're equal anywhere.
No.
But what do we know about the sum of x plus this one plus y?
It has to equal 180.
Okay, and the middle line is how much?
90.
So x
So it'd have to.
plus 90 plus y has to equal 180.
Uh-huh.
So x
So it'd have
plus
to be.
y equals 90.
So 45 plus 45.
No, they're not equal. They're not asking for what x is or y equals. They're
Just the
asking
sum.
for the sum. That's all they're asking. And that's the only thing we can figure out. If they
Yeah.
were asking for x or y, the answer would be this. It cannot be determined from the information given.
Hmm.
All this tells me is that they're adding to 90. It could be 30 and 60. It could be 45 and 45. It could be 31 and 59. Because all I know is that they add to 90.
Okay.
And I only know that because of this equation. In other words, you always want to start out your geometry problems with an equation that you can solve.
Okay. Yeah, that makes sense.
And if you start out like that, then you can solve for x plus y. And that's all you have to solve for.
Okay.
Six.
Okay. In the figure above, EB is perpendicular to FC, and AD and EB intersect at point F. What is the value of X?
Again,
Okay.
everything they state in this can be discerned by just reading the picture. You
Uh-huh.
almost ignore the rest of this. The only thing you need to know is what are they asking for, and even that, you know, looking at this picture, that they must be asking for X.
Yeah.
The only thing that's not labeled, you know. So you really don't need to read any of this to know what they're asking for.
No. Okay, so you would just do 90 minus 40 to get X. So that'd be 50. Is that right?
Uh-huh.
Okay, cool.
Yeah, don't be shocked if you get more than 2 pages for homework because some of these only have 2 questions on them.
Yeah, exactly. Nah, don't worry. Okay.
Number 8. Hold on.
Okay.
Now this is in the intermediate section, so this is liable to be a little harder.
Mm-hmm.
But not really. You may not have seen anything quite like this,
Mm-hmm.
but this is the kind of geometry skills you really need. Combining geometry with algebra.
Okay.
Alright. V is equal to 2W.
Mm-hmm.
W is equal to 2x. And x is equal to y over 3.
Mm-hmm.
Want the value of y. So, how should I label these?
Well, like on the picture.
In other words, this picture is labeled VWXY.
Yeah.
They've given us all of these equalities here. So obviously we have to use them.
Yeah. So we could do
Labeling that V, what should I label it?
2W.
Alright, for starters. What should I
And then
label W?
2x.
Okay. And what should I label X?
Y over 3.
This one can stay Y because we're trying to solve for Y, right?
Yeah. Mm-hmm.
Now, X is Y over 3. Let's relabel that in terms of Y. What should I label that if that's 2X? Let's label it in terms of Y.
2 times y over 3.
Yep, perfect.
Okay. Okay.
2y over 3, and it doesn't matter whether I write that 2/3 y or 2y over 3, as long as I don't put y in the denominator.
Okay.
Okay. Well, now the only one that's not in terms of y, in other words, if I can get all of these in terms of y, then I can just add them up, let them equal to what?
180.
Okay, and solve for y, because I'll have one variable only.
Okay.
So I got to figure out how to label this one in terms of y. Well, w is 2x, so 2w, for starters, I could label it as 4x.
Yeah, because you're just multiplying them.
Right. Now what? How do I turn it into y?
Instead, we did that.
Similar problem. No.
So to turn it into y,
what's x equal to from down below?
x is equal to y over 3.
What's 4 of them equal to?
Y over 12.
No.
Wait.
You divided by 4. In other words, this is 4x. So just substitute for x. What is x?
Y over 3.
Okay,
so instead of
x, I'm going to write y over 3.
Yeah.
Okay?
Okay.
And 4 is in the numerator.
That's
the same as 4/3 y. Now, what's my equation?
So now your equation is going to be 4y over 3.
Well, let's make it like this. 4/3 y.
Okay, plus 2/3 y. Plus y over 3.
No. State it in a similar format.
Oh, yeah, my bad. Plus 3y.
1/3 y.
Oh, because it's y. Okay, yeah, my bad.
3 is in the denominator. You got to make sure it stays in the denominator.
Yeah.
It's a big difference. 1/3 y and 3y. What's the rest of it?
Plus y is equal to 180.
Okay. Now, how much is 4/3 plus 2/3 plus 1/3?
7/3.
So we have
So it'd be
7/3 y plus another
y.
full y. How many thirds y's do we have now? In other words,
8.
no, 10.
Oh, 10.
That one is 3/3. In other words, if we go to find a common denominator, we're adding these 3 to this one.
Yeah.
Well, 7/3 doesn't add to 1, but it does add to 3/3.
Yeah, so it'd be 10
Notice
thirds.
that that's the same as
Yeah.
this. I have not changed its value. 3/3 y is the same as y.
Mm-hmm.
So it's 10/3 y equals 180. Now how do I solve for y?
We could do 180 times 10 divided by 3. So it'd be 1800 divided by 3,
Hold on.
which is,
Hold on.
okay. Mm-hmm.
I think I've probably confused you by pointing out that there's 2 ways to do this.
Mm-hmm.
You might be better off using the way you wanted to use all along. How do I solve this equation?
Divide by 10 thirds
Okay.
on each side.
Let's stick with that.
Okay.
Now, that we know that's going to get rid of the fraction over here, right? By definition.
Yeah.
The fact that
Yeah.
we're doing the inverse, we're dividing by something that's multiplying, assures us that we're going to have y.
Mm-hmm.
How do you do that?
Well, you could do 180 times 10 divided by 3.
When you're dividing by a fraction, what do you do?
Oh, put it 180 over 1.
Well,
You have to find a common.
that's the important part. What you do with the numerator doesn't matter. It's what
Yeah,
you
you
do
have to
with the
find common.
denominator. No, it's not common denominator. We're not adding or subtracting. That's only when you add or subtract. When you divide by a fraction, it's very specifically the same as multiplying by what?
3 over 10.
Yes, by multiplying by the reciprocal.
Yeah.
That's the key.
Okay, gotcha.
Which gives us an
Um,
answer of 540. That's 3 times 180
mm-hmm.
over 10. Or I could just do this. 3 times 18
Which,
is 54. So
yeah,
54 is the answer.
that makes sense.
Okay.
Okay.
So another great problem was this problem because it involved all kinds of algebra, substitution, and knowing that the sum of any set of linear angles is 180.
Mm-hmm. Yeah.
All right.
Okay. Cool.
And number 10, parallel lines. They cover exactly what's big, what's important. Not that your geometry class does not. I mean,
No.
I'm not criticizing them because they have a whole year. The problem is geometry should really only be a half-year subject.
Yeah, I agree.
By making it a whole year subject, they force them to cover material that's way outside the bounds of any geometry you'll ever need to know again.
Yeah, exactly.
All right.
Okay.
Here we have 3 parallel lines. What do I know about E and D?
We know that E and D are supplementary or linear.
What do I know about E and C?
E and C, they're linear.
Not linear.
Well, they are corresponding.
What are they?
Course.
Are they equal or are they supplementary? Because when you're dealing with parallel lines and a transversal, that's the only 2 answers. They're either equal or supplementary.
Yeah.
In other words,
So
E and D are supplementary. And they are a linear pair. And they are also adjacent. But
yeah.
E and C are not adjacent. They are corresponding, but what does that mean about them?
It means that they're, I, well, they are, my brain just went blank. They'd be
Are they equal or are they supplementary?
equal.
Okay. Or congruent.
Yeah.
Okay.
Or, yeah, or congruent.
Okay. What's the relationship between B and C?
They're vertical.
Which means?
Which means that they're equal to, well,
Correct. They're equal. Vertical angles are equal. And
yeah.
remember, whenever we're dealing with a picture of parallel lines and transversals, our answers are only going to be they're either equal or they're supplementary.
Okay.
Okay, that's it. That's what makes
Yeah.
parallel lines pretty easy. There's really
Okay.
only two things. And if they're both acute, then they're equal. If they're both obtuse, they're equal. But if one's obtuse and one's supplementary, if one's obtuse and one's acute, then they have to be supplementary.
Uh-huh.
Okay.
Okay.
So what's the relationship between B and A?
The relationship between B and A would be alternate.
I
Oh,
don't
they're
want
not
that
alternate.
relationship. I want one of the two answers. They're either equal or they're supplementary.
Supplementary.
Okay. Because one's acute, one's obtuse.
Yeah.
Okay. So now to figure out the answer to the question, A plus B plus C plus D plus E, let's write it. A plus B plus C plus D plus E. What's A plus B equal to? You just told me?
A plus B is equal to 180.
Okay. What is C plus D equal to?
C plus D is also 180. And then D plus E would be 180 as well.
That's true, but do we know what E is?
No.
There's no way to tell. They have not given us notice that there are no numbers anywhere on this problem. Okay? And yet we got it down to 180 plus 180 plus some angle E, which we have no way of measuring or knowing what it is.
Yeah.
So
that cannot be determined.
Cannot be determined from the information.
Yeah.
All
right. Okay.
This geometry should be a little bit more enjoyable also, I would think.
Yeah, it is, yeah.
This is geometry. I mean, what they teach you in geometry classes sometimes, now this is advanced, okay?
Okay.
And just for your information, this is the basic geometry that they are teaching college graduates to take the exam to get into graduate school.
Wow, that's insane.
And I'm not kidding. So, in other words, there is a basic set of geometry you need, and that's what you want to return or retain.
Yeah.
It's not just about getting into college, but even when you get through college, no matter what you major in, if you go to graduate school, you're going to have to know all this stuff again. But it's not that hard. That's what's amazing. You would think that to get into graduate school, it would be much harder basic math, and it isn't.
No, it's not.
So the basic math you really want to be strong on is algebra and geometry. And,
yeah, like with my mom, like with her graduate school.
I know you probably feel like, well, math isn't your thing, you don't much like it. And everybody probably says, well, you'll never have to do algebra in your life again, and things like that. But
that's not true.
Well, here's the plain fact of the matter, and that is that society values quantitative thinking. It's not so much that you need to know all of this math, but you got to prove to society that you are a good quantitative thinker. You can analyze stuff quantitatively, not just qualitative. In other words, you might know that a piece of art is better than another piece of art. That's qualitative analysis. But quantitative analysis would be this piece of art's worth 100 million, this other piece of art's worth 30 million. That's quantitative analysis. So math, regardless of what you're going to do, even if you became a professional baseball player, there's
batting average, you know.
It's not batting average, but there's a lot of logic in baseball, which I continually see destroyed by major leaguers that don't understand it. When you are, and I'm sure you probably do, when you are in the ninth inning of a game and you are down by 5 runs, and your leadoff batter hits a home run, that's silly.
That is,
right? I mean, you understand.
It almost never happens.
Well, no, it does. It happens in major leagues a lot because they're trying to pump up their statistics. But if they were really trying to win the game, they would realize that a walk was every bit as valuable as a home run. There's no extra value from hitting a home run when you're down by 5, or down by 4, or down by 3. If you're down by 2, the only way you win the game isn't if you score, it's if the guy behind you scores. Right? So even if you're down by 2, a walk is as good as a home run. And that comes from mathematical thinking and logic. And yet you continually see it messed up, even at a major league level. And
that's exactly
messed up at high school level all the time. But it's a fundamental thing, and you can almost take that same strategy and back it up from the 9th inning. It isn't necessarily true in the 8th inning that all of those things are true, but it's more true. In other words, in the 8th inning, a walk is maybe not as valuable as a home run, but it's close. If you're down by more than 1, you need base runners.
Exactly. You need as many people on base as possible.
Right.
Yeah.
You see Carlos Gonzalez coming up to bat in the 9th inning, and the Rockies are down by 5, and he hits one out of the park.
Yeah.
That tells me
it's not that helpful.
No, it's not only not helpful, but it means his motivation wasn't right.
There,
He could have been going for a single or a walk, which are just every bit, 100% as valuable as a home run is. 100%.
Exactly.
And from defense, it's the other way around. Obviously, the pitcher should never be throwing balls there.
No.
Pitching, and you're up by 2, you throw nothing but strikes because you don't want to walk a guy. It's the same as giving up a home run ball.
Yeah, exactly. It's just as bad as devastating for the pitcher, you know.
So, and of course, you've probably seen the movie Moneyball, which was it revolutionized baseball by introducing quantitative analysis. It takes every baseball player and rates them on some exotic system, a stat that had never been around before. And a lot of the stats that baseball uses are not stats that, if you were making it up today, they would be completely different. How come you have batting average, but you have home runs? It should be batting average, home run average.
I agree, yeah.
Or total number of hits, total number of home runs. Let's compare apples to apples and not apples to oranges. And yet they repeatedly compare apples to oranges. You know, they rate batting average, and then they compare to home runs or RBIs, which are absolute numbers instead of rates.
Yeah.
So,
and
it's like that with any branch of life. It does not matter what you go into. Everything requires good quantitative reasoning power.
Yeah, definitely.
And that's the importance of math. It's not so much that when you're 25 years old, somebody's going to give you an algebra problem to solve. That's probably not going to happen. But
probably not, but yeah.
And the way people find out if you have quantitative skills is by giving you tests on algebra and geometry, basically.
Hmm. Yeah.
So,
Yeah.
boy, I mean,
Yeah.
so there's my motivational speech.
Yeah, that was a good one.
Anyway, Dylan, I guess I can send it to your mom. I don't think I have your email address.
I don't think so. Do you want me to give it to you?
Yeah, give it to me.
I have it right here.
Yeah,
Right here.
let me write it. Go ahead.
Sure, it's, let me make sure I'm giving you the right one, because I have a couple. Yeah, it's 10, it's my school ID, so it's 1077538
Okay.
at jeffcoschools.us.
That's Jeffco Schools with an S .us.
Uh-huh. Yep.
I think
Exactly.
you might have that somewhere. I don't know. But that's where I'll send the homework to.
Perfect.
Yeah, it'll just be the stuff we looked at today and just do the odds.
Awesome.
Shouldn't take you
That sounds good.
too long. Yeah.
No, not at all. Yeah.
No.
Awesome.
Okay.
All
Talk
right.
to you Friday evening. Friday
That sounds good.
5:30. Okay.
Okay. Is that a half hour or no? That's not.
That's an hour. It's the Sunday one that's currently set for a half hour.
Okay.
Okay.
All right. Sounds good.
Bye bye.
All right. Thanks, Mr. Cowan. Bye bye.